So we're going to start the last unit on chapter 14, 14C. And maybe you remember when you were back in your geometry days, you probably did a unit where you talked about the law of sines and the law of cosines. So we use sine, cosine, and tangent a lot to find like sides and angles of triangles. Those are always right triangles when you use the normal, sine of the angle equals opposite or hypotenuse. Okay, those are right triangles. And most of the time, you're doing construction, you're doing things where you might use trig ratios. Often things are right triangles, right? Because we use a lot of rectangular kinds of corners, right? Most of our houses aren't weird, odd shapes. So just everything is typically vertical and horizontal lines, and you get a lot of right triangles created that way. But sometimes triangles aren't right triangles. So when you get to this lesson here, we're going to talk about the areas of triangles. So remember, from algebra 2, you solve the area of a triangle is base times height divided by 2. That is if you know the perpendicular height. So when you were in geometry back in the day, we don't actually have to do these problems, but if this would be a nice right triangle. Area equals 1/2 base times height divided by 2. So 4, or I should have done 9. It doesn't really matter. 4 times 9 divided by 2. You have to know the perpendicular height to use this equation. And probably that's all you've ever done. So this one, you could say, okay, well, this is the base, and this is my perpendicular height. So it would be area equals base 9 times 6.4. That's the height over 2. You could find out what that number is. Or you can have weird obtuse triangles like this. The 2 is the base, and the perpendicular height we kind of draw on the outside, which is kind of weird, right? But this would be area equals 2 times the height, which is 3.8. That's kilometers. That's a really tall triangle. Goes right up into the sky. You'd have something like that, and you could find out what that is. So that is kind of what you maybe used to do in terms of finding areas of triangles, including the second and the third triangle that were not right triangles. All right, moving along. There's another formula that we can use for the area. And again, I'm not totally sure you got to this depending on your geometry teacher, because this is usually kind of a bit of an extension that you do right at the end of a trig unit. But there's these other formulas. So basically any triangle you have, okay, with sides A, B, C, and angles A, B, and C, like you see here in this picture, you can use any of these formulas, and you just kind of set it up however it works. You need to know one of the angles. So typically, if that's the angle, you're going to set that up like angle A, right, for that one. And then you need to know sides B and C to make it work. And then you can find the area. Your calculator needs to be in degree mode in order to do it. Let's go ahead and look at this problem. So here we have a triangle, and this is going to work out. They're giving the first one to us quite nicely. They're giving us angle A, and then they're giving us the sides that are next to it. This would be side C because it's across from angle C, and this would be side B because it's across from angle B. So we can use that formula, area equals. I always think it's a good idea to write the formula out. But, I'm also a teacher, and teachers like to write out things like formulas because then at least you can tell if a student knows what the heck they're doing. All right, so there's the area. So area equals 1/2 5 times 10. And then sine A, sine of 31. You could just load this whole thing into your calculator just like that. I will do this one for you. Do make sure your calculator is in degree mode. Go to mode, and mine is in degree mode right now. It's that third, fourth line down. So we'll do 1/2. Could have also done 0.5 there. Maybe I should learn to type. 1/2. And then this is going to be, what do we say? 5 times 10 times the sine. It's a struggle today. I can't seem to touch the buttons correctly. I'm kind of at a weird angle with my hand, and I know that's probably information you don't care about, but that's why that was hard for me, and that's my excuse. All right, so I hit enter. It is 12 point, and let's just round. It said round to the nearest tenth from square mile, so that would be 12.9. You can do miles squared or square miles, however you want. Area is a square dimension. Why don't you pause it, do the other problem, and then we can kind of check back and see how it went. Okay, so in this problem, it didn't give us a picture and it didn't label the angles. It doesn't really matter. It does say, I mean, it does and it doesn't matter. It says that the sides are 12 and 15 and the angle between them is 24. So as long as the angle between the two sides, you know, just like in problem one, you got your two sides, as long as the angle between it is the angle they give you, then you can just go ahead. I decided to use the one with AB sine C, but it doesn't really matter. I put the 12 and the 15 in here for my sides and then the angle. You do have to, I mean, if they were to give you some sort of other angle, then you might have to do a little more work on that, but basically that's what works. So I'm going to pause this and we'll do the next part in the next video. Okay, so like I was saying before, kind of at the beginning of the last video, okay, you already know how to find sides and angles of right triangles. You've been doing that for a while, and that is the most common way. The whole unit circle is all based on right triangles and all those ratios. So like sine is opposite over hypotenuse. But those only work for right triangles. So if we have a triangle like the one you see here in this red square or rectangle, you cannot use law of sines on this triangle. It's not going to work. So instead, you need to use something called the law of sines. And in tomorrow's lesson or the next lesson, I go through kind of how you get the law of sines, which is kind of an interesting little proof, but we can kind of go through that. It's interesting why it works, okay? But this is the law of sines. And basically, there's three ratios: sine of the angle divided by the side across from it, so sine A over sine B, and then the same for sine B, angle B and then C. And you only use two of these to make it work. So what you need to make sure, like let's say it's this one that you're going to use. You have four things. You need to make sure you have three of those four things. Okay. Otherwise, and then you're just going to do cross multiplication, right? So like if I know, oh, this is 20 and this is 70 and this is 14 and I don't know side A, if you can get this set up and you can basically you only have the one unknown and you can find out what side A is. If you don't have the right stuff, you sometimes have to spend some time playing around with your little figure to try to find it out. For instance, sometimes you have to look to find the third angle because you need that angle instead. Well, if you know two of the angles of a triangle, you can easily find the third angle because all angles add up to 180. So you can do little things like that. That's the law of sines. So, by the way, does the law of sines work on right triangles? Yes, it does. It does work on right triangles, but usually we use those other ratios because it's a little simpler. All right, so find the side of a triangle. So you can use law of sines when you have angle side angle or angle side angle. Okay, so if you know two angles in a row and then the next side, or if the side you know is in between the two angles, you know, this is when those ratios will work out where you'll have three of the four things that you need. So here's a problem: triangle PQR, R is 39, Q is 32. Well, you can probably then figure out what P is going to be pretty big here, right? This is about 40 plus about 30. These two are about 70. So angle P is going to be pretty big. So I'm going to make angle P kind of bigger looking, like 110. This is, do not try to make this look like a right triangle. You might, let's make this Q. Let's make this R. And the reason I did that is because this looks more like 39 to me. Maybe this looks like 31. I don't know. Maybe we'll have to find angle P. We might not. Okay. But then it says that PQ, which is the same thing, by the way, this is little side R. Okay. If you want to, sometimes the book writes it like using the two letters and sometimes it does not. Okay. So this is what we have. And it says, what is RQ? RQ is this side, which would be little side P. Okay, so again, you have to kind of look at this. You need to know a side and an angle across from it. So I have the 40 and the sine of 39. So I definitely want to use, this as R. I definitely want to use the R stuff. So like a sine R over little r, because I have that stuff. That's going to be sine 39 over 40. But now I need another set, and the side I want is little p. This is what I want, little p. So I need sine p right here. And do I know angle P? Well, no, I do not know angle P, but I can find it because the sides of the triangle add up to 180. So if I, by the way, that's a 32, not a 31, and I'm sorry about that. So what I can do is subtract 180, 180 minus 32 minus 39, and I get 109. So this will be sine of 109 over little p, and little p is what I wanted because that's the same thing as RQ, which is what it wanted. So now you can cross multiply. So you're going to have little p sine 39. I was multiplying like this equals, and then 40 sine 109, and then get little p by itself. You might as well do all this without actually finding the ratios. When you find a trig ratio, you really are supposed to use like 4 decimal places, because small changes in the ratio can kind of have big differences in the answer. So just write this whole thing in on your calculator. So let's go ahead and do that. It's going to be, and I'll try to do better than I did the last time, 40 sine 109. My goodness. 1 divided by, and you have to end parenthesis after that 109, otherwise that's next sign is going to be embedded in the first one. You don't want that. Sine of 39. Enter. You get 60.01. And it does say, it says round to the 10th or whatever. It said round to the whole number. It would just be 60, right? Let's say 60.1. So little p, or RQ as they wanted to call it, is 60.1. And that doesn't have any, oh, it does, centimeters. All right, so that's one problem. So why don't you try to go ahead and do this got it problem, and then see what you have when you check back with me. I'll do it here off, you know what I mean? So next time you start the video, it'll be done. All right, so for this got it problem, I tried to draw a triangle as good as I could, with K being kind of an obtuse looking angle. We got 50 for M and L. Maybe we'll need to know that, maybe we won't, okay? But when I do this problem, I do have all the K information. I have angle K, which is 120, and I have the side ML, which is the same thing as little k, right? So I can set up this ratio, sine 120 over 35. I have that kind of pair of information. What I want to know is KL, but that's the same thing as like little m, and that actually is already across from the angle I know. So I don't need to go find angle L here. I know this angle, so that's sine 50 over little m, which is the same thing as KL. Multiply, cross multiply them, and then I divide by the sine 120, and I get this. Throw that whole thing in your calculator. If you're rounding to the hundredth, that's 30.96. If you're rounding to the 10th, 31.0. If you're rounding to the whole number, 31. And this was yards. All right. So that's how you do the law of sines. You've got the area stuff that we did in the first video, and then this stuff, and you should be set with law of sines.